Welcome to qnawire.
To solve this problem, we will use equation 11.13c for the precessional angular velocity, which will be given by mgr over I omega, where r is now the center of mass of the combination of the wheel and the additional mass that is placed on the axis of rotation. Now, since the mass, which is half of the mass of the wheel, is placed on the axis of rotation, so it does not contribute to the total moment of inertia. So, moment of inertia due to this mass about the axis of rotation is zero. Therefore, the total moment of inertia will still be same and will be equal to that of the wheel, which is mr square. Assuming the wheel is a circle now. But we don't need this expression now, so let's forget about that and let's just call the moment of inertia, the total moment of inertia, equal to the moment of inertia of the wheel, I. Now the addition of the mass does not change the center of mass, but it does change the total mass, which is now equal to mass of the wheel plus the mass that is placed on the axis of rotation, which is m over 2. So the total mass is now 3m over 2. Now let's find the center of mass. So R will now be equal to, so we will use this formula for the center of mass. So m1 is the mass of the wheel, so that is m. x1, which is the distance of the wheel from the axis of rotation, so that is L over 2, the radius. M2 is the small m, and x2 for that is just L, which is length of the axle. And total mass is 3m over 2, m1 plus m2, as we found here. So this gives the center of mass to be equal to 2 over 3 times L. Now we can use this equation to find the ratio of the new precessional velocity over the original or old one. New mass times g times r new. So this is basically r new now over I omega, and I and omega stay the same. So we arrive at this equation now. Now we simplify this equation a bit. So these terms cancel away. Now m nu, which is the total mass now, is 3m over 2. R and r nu is this distance, the new center of mass. And m old is just the mass of the wheel before the small mass was added at the center, so this will be equal to just m, and the center of mass of this will be half of L, as we wrote over here. So this gives the ratio of both the precessional velocities, precessional angular velocities, to be equal to 2. Now we can use the answer from problem 55 to substitute for this old precessional velocity, which we got to be equal to 8 radian per second in problem 55. Therefore, the new precessional velocity will be 2 times 8, and so this will be 16 radian per second.